So that brings us to a so-called tournament predictor. The idea is that you have two predictors. One is better for some branches, the other is better for other branches. Now what you want to do is to get the best behavior for all types of branches. So what you want to do is, when you have these branches, use the first predictor. When you have these branches, use the second predictor. But you don't know which branches are going to benefit from which of your two predictors ahead of time. So what you really have is your two predictors. Let's say that they're G share and P share. You will use your PC of the branch to index into both of the predictors. You will take the decisions that they generate, and now you need to decide which one to use. How do you do that? And the idea of a tournament predictor is to use a so-called meta predictor, which is just an array of 2-bit counters. You also use the PC to index there, and the entry of the meta predictor does not tell you a prediction for the branch. It tells you which of the two predictors is the more likely to give an accurate prediction for that branch. So what you do is you use this to choose among the two decisions. So pretty much this meta predictor gives you a way to select among the two decisions so that the final outcome is the decision that the meta predictor thinks is a better prediction. You train the individual predictors just like before. On every branch outcome, you train each of the predictors. You train the meta predictor a little bit differently. Instead of counting up when taken and counting down when not taken, the meta predictor is instead trained on how well these two are doing. If your two predictors are both correct, then your meta predictor doesn't change anything. If your first predictor, like in this case your G share, is correct, but the other one is not, then you count down. Counting down will result in selecting the G share result more often. If your first predictor is wrong, but your second predictor is right, then you count up. Counting up will result in choosing this prediction more often. And finally, if both of them are wrong, then the meta predictor doesn't change, because again, there is no benefit in trying to select one over the other. So the idea of the meta predictor is that the prediction bit of the 2-bit counter is telling you really which of these to select. The hysteresis is there just in case G share is overall the more accurate, but sometimes P share beats it, or the other way around. And again, each branch has its own meta predictor entry, so this type of decision and this type of selection is done dependent on branches. So pretty much for your, for example, loop exit branch, it might be that the P share works better. For your correlated branches, it might be that the G share works better, and they will have different meta predictor entries so that they will use different predictors for their outcomes.